Okay, everyone, welcome to week 10 of OIT-Sec. Yeah. I'm going to please sign in so we can keep attendance of who's here and who's not, your membership and everything, all the good stuff. Check out our interest groups and programs. They're really cool stuff. Look them up. Do stuff outside of the club. Again, really interesting. Check out our workplace if you haven't already. All the stuff's on there. And pretty much all announcements. Please join it if you haven't. Sign up for the newsletter, get newsletter before you come, know it's coming. See the presentations before you know. All that good stuff. And hack night, again, every Tuesday, 7 to 9, Sys Lab. Do homework, do challenges, hang out. Really good time. I really enjoy it. Again, I do crypto, kind of cry. Pretty hard, but it's a good time. Me ends a struggle. We're cutting farms this Sunday. I'm gonna go out to the cornfields, go into mazes, maybe get lost, maybe not. But I think it's gonna be fun.
Which you mentioned, hey, if you need a ride and you can't find a ride, just message somebody.
Yeah.
We'll figure it out.
Yeah. If you didn't hear John, if you need a ride, message someone and probably get one. Remember, it's by the way, it is $15 if you do want to come. For overcome. Hats. Again, the form's out there.
What is that?
Yeah.
What is that?
It's probably check workplace for a better link than that.
That's gross, bro.
But yeah. Hat forms, if you want to order some hats, they come to you. And meet our sponsors. Everyone get a round of applause for our amazing sponsors. We love them. They're awesome. And follow us on social media, Instagram, Facebook, and Twitter. And without further ado, Emmanuel.
Okay, so today, can you guys see that? You'll be fine.
Uh-oh. Complete screen, man. You got 17,000 weeks. Hit blank. Swipe over. Hit blank. There you go.
Okay.
Session. Oh my God, my battery just died.
Okay, there we go. Can you guys see the presentation on stream? Okay. This week is mobile security by me, the tech lead, or also known Potato. Let's go. Okay, just before we start, there's a lot of text because people were complaining. I write a lot, but if you guys want to know something, sometimes you need text. So there's a lot. And also, I'm not great with memes, so if it's not funny, it's not my fault. I tried. Let's start. Okay, what is mobile security? Well, before we talk about mobile security, you need to know what mobile operating system is. It's pretty much an OS that's specifically designed to run on your phone, tablet, fridge, whatever. Pretty much IoT related stuff now. So that little software is called, it's a mobile OS. And mobile security is protecting those OS from attackers out there. So you're protecting sensitive information on the device. So if you have a phone that's for some reason storing your phone number and all that sensitive data on your phone, mobile security is there to protect that. And the goal is to prevent unauthorized users from accessing those data. So obviously we know there are two main operating mobile OS out there, Android and iOS, but there's others, but these are the top ones. And Android currently leads is the lead in the amount of devices out there that has Android running, and Android is about 85% of the market share right now, and iOS is just 15.5. It's different to what I was talking about in the Mac OS malware. For some reason, it's flipped, but in this case, Android is winning. And Android is basically Java and now introduced language, Kotlin. It also supports C and C++, but that's for native applications, but most developers use Java and also Kotlin. It can be developed on any machine. So again, your phone, tablet, watch, whatever. And it's designed by Google. It's based on the Linux kernel. So Linux kernel, just a modified version, make it smaller to work on everything. iOS, that is Objective-C and Swift, which is what Apple created, I guess, to make it easier for developers. I don't know much about iOS. It's only you can only develop iOS apps on Mac OS, except you do a cross-platform application. Then I think it's Objective-C that works with both operating system. But if you're just designing just for iOS and Mac OS, the Apple ecosystem, you kind of need a Mac OS to do that. And that's how I got my first MacBook, because I was trying to do iOS development. Again, it's developed by Apple for the specific hardware. Yep. So again, the file system for Android, since it's based on the Linux kernel, it looks exactly like if you do ls on the root directory, it looks close to the Linux file system, except with like two new folders, which is the SD card, which is where apps store like all their datas and all that fancy stuff like configs in databases and all that stuff. The SD-ext, which is extension, is just for external storage. So if you have a Samsung and you use all your space, you can expand that by just plugging in an SD card, and all of that goes in there. So a protection to that keeps apps from like just doing whatever in the file system. It's first of all, the root files are not accessible by generally not by any apps or the user. It's protected, except you root the device, then you become root on, it's like root on a Linux system. So you become, if you root your device, you become root and you can do whatever you would do as you please. Usually files are sometimes worldwide readable and writable. So that's just there. And again, Android has gotten a little better with the way it isolates apps, and now most of the apps, all of the apps are sandboxed, so they don't have to talk to each other except they need to. By default, they're all sandboxed. So the question is Android Linux? Well, the answer is no. No, maybe, because it's based on the Linux kernel, so it does have some similarities between them, but overall it's different. The Android Linux, the Android operating system uses the DVM. I'm not going to say that word. It's like it's where you take your application and it's like a VM for your applications, pretty much. And that was what was being used for like the beginning of Android to Android 4.4, but it got changed to Android Runtime, which has some features like better garbage collections and better debugging features, and it makes the app run faster. So other apps talk to the kernel. Like if an app needs to use the microphone, how does it work? So an app talks to a framework. The framework uses a library, then library to kernel, like that. Easy to understand. So you want to reach your device. Well, there's so many tutorials out there that tells you how to reach your. This is the only good meme that I have, so I'm excited for that. But yeah, rooting your device is like jailbreaking iOS, and it's you give you full access to the whole phone, but if you do it wrong, you might break your phone, and you might break your device and just lose everything. So first of all, make a backup before you attempt to do anything. And also, it voids your warranty with whatever company, wherever your phone is coming from. So if you really don't care, good for you. If you do care, just it doesn't matter. You'll be fine with just the regular default, whatever it comes with. So with such power, what can you do? Well, you can, again, you have full control. You can turn your device to literally a network spoofer. You can just walk around with your device and just spoof whatever network or whatever, yada, yada. Uh, yeah. You can also customize I believe you can change the way the Android kernel works if you have full access and you know what you're doing. So if you don't know it, don't touch it. So iOS. Well, I'm not a big iOS developer, so I don't know much about this, but I do know that every app is extremely isolated. It's so painful to escape the sandbox. But if you want to, the easy way is just asking permissions to like use some resources on the app. So like music, contact, pictures, all that stuff. That's a potential way to escape the sandbox. But applications are stored in bundles, and in there it has all the config it needs and the executable itself. So when you download an app from the App Store, the icon you see is not exactly the executable. Inside of that, there's a bunch of folders. It's not on that picture, but there's a bunch of folders. And if you get to, I don't remember in the top of my head, but in some folder, there's an executable, which is the actual application. But in there, it also has the icons and all that fun stuff. So how do apps store data? Um, Well, the easy way is just storing it in a MySQL database. Most applications do that, and some applications just save it in any directory and they leave it as the default permissions, which is read, write, execute on everything. So that's not good. But remember, the apps are stored in bundles, so it means that everything that the application does is also in that little bubble it has. And again, it stores in database system, so MySQL, SQLite, and on Android, there's multiple storage techniques. One of it is the shared preference file. This is mostly used when you have your settings, like when let's say you want a dark mode. When you click on it, it saves it with the shared preference so that every time you restart the app, it just loads this interesting class, and you already checked this to be dark mode, so you don't have to always click on the dark mode toggle to switch between light and dark mode. Again, there's the local device, which is kind of anywhere in the system except the root directories and in the external storage, so SD card. So what happens when you delete an app? Well, again, if it's in the bundle where it's secure, all of it just poof as you delete the app. But if you save, let's say, some database outside of that bundle, then it's just going to be there until someone else comes around and finds it and just use it for whatever they want to use it for whatever. So yeah. Also, sometimes some applications do talk to servers. They save those data out there. So that's also another way apps store data. So what about malicious apps, and how do the App Store and Google Play Store deal with this? Well, first, like I just said, the Google Play Store is for the Android, and the App Store is for iOS. The way Android tries to prevent bad apps is by using something they created called the Google Bouncer, which scans every app for malware and spyware and all that fun stuff. But sometimes it fails, and some developers are sneaky enough to bypass that. So the Google Play Store is cool, but I wouldn't say they're the best at doing this. I hope that's correct. Apple, on the other hand, they are super, super strict with all the guidelines. I think it takes about like months just to upload your first app because they use human testing. So someone literally sits down and tests your app and make sure it's following the guidelines. So it's really hard to go under the radar for Apple, for the Play Store, for the App Store, the Apple App Store. This is what happens when you tell your friends to modify your presentation. Oh my God. So what are some security measures you can do to safely, as an app developer, how can you safely develop your app? First, don't store sensitive data locally, bad. Second, if you're gonna use some network stuff, let it be secure, HTTPS rather than HTTP. Invalid, this is pretty much just like web. The third one is invalid user sessions. So when an app is closed, delete the session cookie, just so that if another app attempts to pretend to be that app, they don't have the same access as the original user. So, and the last one is my favorite. More features equals more problems. So you want to do something fancy, just know there might be more problems in the future. So if you don't need it, if you do not need it, don't do it. Reversing Android app, my favorite. Okay, if you remember from my reversing series, this is some of the applications you can use. And I think I didn't talk about this too, but the compilation is the process of converting the software binary, which is, again, if you remember in the iOS part, the binary itself, it's stuck in the bundle. It's the ability to take that and convert that to a high-level language, so the byte, to something you can read. And this assemble does not convert the binary to the high-level language, pretty much the opposite. Okay. Oh, I really moved this all around. But how do you make an app? This is all in, sorry, before I continue, this presentation is mostly about Android because I don't know shit about it. I don't know anything about iOS. So how do you make an app? Well, again, most developers use Java. Now they're moving to Kotlin, and the Java file gets compiled. That's that class. Looks like just how Java does it. Like when you just have a Java program itself, it's pretty much the same. Then the DX tool creates them to a DEX file, which is, this would be put in that Android VM to run the app. Then with that converts all of that and put all the resources, so your icons, your screen stuff, and all that, like pictures and sounds, all of that, and puts that all together into an APK package, which is what you click on, and voila, you have an app. And the reversing process is the flip one. First, you take the DEX to a jar, file. So you can use DEX to jar. Beautiful. Then you decompile the jar, you break it, and this is where you get you take that weird DEX code, no, the jar code, and get to a higher level language so you can read it. And boom, you have the source code. If it's not obfuscated, then good for you, because now you can just read it like a regular Java code. If it is obfuscated, it's going to take a little longer to read, because instead of like the variable names, it's more like A.B, A.B.C, and just get really annoying to kind of track back, but it's just going to take a long time, but voila, magic. So, or if you're too lazy to do that manually, there's this beautiful framework called MobSF. It is an automated tool, takes pen testing, malware reversing, security assessment, and just ports that into one box, and it does everything for you. So both your static and dynamic analysis, it just spills that out to you. So if you don't want to, again, if you don't want to do this like step by step, this tool does it for you. If you don't want to download it, there's a Docker version of it. So that's also an option. Lazy people. So how do we start? You somehow get your APK. There's multiple ways. If it's from the Play Store, you can, there's a website where you can just pass the URL of the location in the Play Store and just put it there, and it gets the APK and you can just download it. Or you can really plug in your device and just do some command line magic and you can extract the APK from the phone. Multiple ways, up to you. So, but first, you use some of the tools I talked about in the previous slide. Get an idea of what that application is doing. Maybe what it's supposed to do and what it's not supposed to do. So just get an idea of what it's doing overall. And pay attention to detail because the decompiler tries its best. So it does not always gets the original source code. So just pay attention. Sometimes the codes are inconsistent. The types are wrong, but again, it tries its best. So pay attention. Second, this is demo time, almost demo time. When you got in the semi source code, now you need to, there's locations you can look into that are interesting in any just Android version. So first thing I do is look into the Android manifest. It is the config, kind of like the entry point of an APK. It tells you all the screens you have, all the permissions the application needs, and if there's any services that's going to be running, any receiver that listens for any broadcast messages, it's all in there. So that's always the first place I go. And if you do find services, try to find that service source code and see what exactly it does, because some services just, again, just like a red teamer or just any malware out there, it's probably going to be doing something like running, trying to get like a info about your application and send it to some server somewhere. So always look into that. Broadcast, this is in Android. You can, much like networking where some devices just yell out just to see who has what. Android does the same thing, and you can send out a broadcast message. And if you have a specific receiver that's listening for that specific broadcast, you can do whatever it's supposed, whatever the receiver does, whatever it's supposed to do when it gets that special message from the broadcast. Also, if the application is storing some data, look into where it's storing it on the phone, and if it's most likely it's possibly readable by everyone, so that's also a good place to look at. And if the application is calling out somewhere, check the protocol, because people are lazy, so they would rather just use an HTTP server rather than HTTPS, so that's also a good place. And going back to the first one, Android manifest, actually, yeah, manifest. In that file, it tells you the list of screens. So every screen you see is called an activity in Android, and it's always stored in the manifest. And sometimes you can have some screens that are not accessible from the app, but if it's an exported activity, it means that you can call it from anywhere using a command line tool called ADB, which is Android Debug Bridge. We'll get to that later. But yeah, if you see if there's a way to bypass the code flow in the application, that's also a good thing. Okay, I have some quick demo. Let's see if this works. I'm just going to share my whole screen. It's fine. You shared the whole screen.
Oh, Mac doesn't let you do that.
Oh no, it does. Desktop one. Okay, so I hope you guys on stream can see this, but this is.
Make it larger.
I don't know how to do that.
I'm gonna make it larger. I'm gonna take away your beautiful face, Emmanuel.
I have no face. They cannot see me.
Yeah, they sure can.
Okay, I've never zoomed in my in this, so I don't know how to. I'm sorry, guys.
Command plus.
No.
There we are. Oh yeah,
It's too small? Okay, I'll forget
you can
it.
do the Mac
That
pinch
doesn't
as well.
work.
Do the Mac the thing with the
It
trackpad.
doesn't. That doesn't work
Oh
enough.
my god, bro. Why are Macs so bad?
Why are you so bad? Shut up. Mac is not.
6.0, which is, I'm sure they'll be good. We'll look at it.
Let's see, full screen. Okay, whatever. Point is, this is what. Okay, yeah, I'm sorry. I should have thought about this. Um, this is a manifest. This is what it usually looks like. Depending on what the app does, there's usually a lot more. But in this case, it's just, as you can see right here, there's this first activities. So it's like, it's XML. So it should be command plus. Yeah. Command control.
Try command shift plus. He was digging around for a hot minute. There's appearance, maybe appearance. View appearance. There's just nothing in there, bro. Why does JetBrains be letting everyone down right now? Yeah, just carry on.
Yeah. I'm sorry. Oh, this part is usually the beginning of the app, like when you start up and the application reads the manifest file, it looks for something called a category. And in that category, it tells you if it's the launcher, which is the first screen you see when you launch an app. So when you see an activity that has like this weird two like spaces, this is just my coding style. So this is how I know what the main activity is. But if you do see something like this that says launcher, that means that's the first screen that you see when you open the app. But that's not what we're looking at. The second one, which is, it says the name of the activity, but next to it, it says exported. If that is equal true, that says that you can open that app without like the code, like following the way the app does. So in this case, this is the application. This is my simple application. No. It does this. It doesn't do anything. So if I do anything, it just does that and that's it. There's no way to go to the secret activity. So the way you can do this is by using ADB, which you guys will see later on today. How's it over here? Damn it. Okay. You
This one. Also, it's command scroll with two fingers. Somebody else thinks command scroll with two fingers. But they do be lying before, so I wouldn't be shocked. I did.
Okay, let's ignore that. So when you have ADB installed, you can do ADB like devices. This tells you if you have like a bunch of emulators running, it tells you which one is running, and you can attach to a specific one. But in this case, I only have one, so it makes it easier for us. So back to the hidden activity. Since we know it's there, but we cannot access it, but well, we can access it through the app, the phone. We know that the exported says true. So if it's true, we can just do ADB shell. You do shell AM. I actually don't remember what this stands for. And you start -n. And this part is the package name. So this is usually like if you open one of the Java files, it's the first thing you see right here, when it says package and the whatever, it's what you put there. You put it right here and you do a slash. Then this part would be the secret activity that you cannot access through the phone. So you do that and you just do enter. and voila, you bypass the way the app is supposed to work. Now you got to another screen that's not accessible through the user flow. So that's that beautiful magic. There's more. Yes, I have more demos. I remember this now. So this is one of the VMs I use for um, Android reversing. Just let it spin up. This is made by Maddie Stone. She works at Google. She's a big Android reversing person. So she has a little course on YouTube if you want to watch it. Well, if you want to use it, it's out there. So password. Again, this is an actual malware from out there, like 2013 and all that stuff. So it's outdated. But this application pretends to be, I don't remember, but it was pretending to be some good application. But behind the scenes, we can see that again, this is JDX, one of the tools I said. This is the GUI version. There's a command line version, but the GUI is just better because it has literally all this. You don't have to like vim each file to read it. This just has everything in one place. And so first thing, you look at this and you can see a bunch of the applications, the services, usually a good place to start. If there's no other activities, services are also good, and also the receiver, that's there. Let's say we want to look at the services that operation stuff like this. So this is what the JDX does. It does all like the compilation for you. You know the word I'm trying to say. And it just has all of this right here. Again, sometimes it's not correct, but most of the time, if the application is not obfuscated, it has it right there. So this is one application. It does a lot of things. Like first thing I see now is run command. That's not usually a good sign when the application is supposed to be good. So you look out for stuff like that. Again, exec command, that's definitely not good. So that's one. And yeah, so this application does all of this for you. It shows you all the files that the application have. Like this one does, this is a service and obviously does not do anything good. It has persist, not good just by the name. Admin, yeah. Oh yeah, example like this. Sometimes the decompiler doesn't understand what to do and it just spells out all of this. And I don't remember what this is called. I forgot the name of this language, but it's not assembly. It's like between assembly and Java. I don't remember. I'm sorry, I don't know. But if it's not able to convert this to the Java code, it just gives you exactly what it is. But it's also good to like know a little bit of this, but you don't have to because sometimes it's just looking at it just stands out because the first thing I noticed was change mod 600. And I think that means read, write, execute for all of it. So that's 777, but this is read, write, read. What is it? Yeah, read, write for whatever file this is trying to create. Well, it says this file, so it's creating this file. My point is that you can have this beautiful application, JADX GUI, JADX, just do it all for you. If you're really just like me and just lazy and just plug it in there and just boom. So this is one thing you can do. I think that's all I had for demo. But next, again, back to the ADB. It's used to communicate with devices using that runs on Android. So when you plug in your USB to your device, there's a pop-up that says you want to connect just to transfer files or to charge. And I think there's like another setting that gives you that allows you. It's a developer tool that enables this feature if you need it. That's for Android developers, pretty much anyone. So what can this command line GUI magic do? Well, you can install apps from other than Play Store, like if you need to test stuff and Android is being annoying and not letting you install a particular app, you can just use the ADB command line to install it. It's also used to debug apps. Mainly, I think that was that is the main reason for this because it's right in the name. You can also do some access some features if you want to, and again, it gives you a shell to the phone. So that's always good, right? And there's this beautiful tool, Frida. It's used for dynamic um, analysis. It's it's JavaScript, so you have to write some JavaScript to use it. So if you can think of this as system hooking in Linux. If like just if you write a lot of rootkits, so just know a little bit about them. Rootkits, what they do is just hook a system call and do whatever they have to do. Frida is similar to that. It injects whatever JavaScript you have and injects it into the application process, and again, does all that and does whatever you tell it to do. I would have had a demo, but it's didn't work for me when I was trying it, so I'm sorry. Um, it hacks like a server client relationship. The phone is going to be the server, and you on your device, your host machine, and in the command line that would be the client. So you would need to install Frida on that. You would need to do some, yeah. So I believe you have to install Frida on the phone so you can connect to it and do whatever you have to do. So if you need help, I can help you. I can help you installing it because I'll say you need it. Wink, wink, for the challenges. And is that good? Okay. I forgot to change my slide. I'm sorry. The last one is pop the shell. That's what I meant to write. Pop the root shell. So when you find something, shit, I can't even continue. Okay, I hope you guys got the joke. So again, pretend like this is not there. It says pop the shell, yada yada. Once you find like a potential vulnerability, you know what's again. I said it, pop it. So you can do first of all check if you can access if it's a database stuff. See if you can access it directly on the phone. If it's a network traffic, Burp Suite is your go-to. Well, that's what I use. It's like there's another tool, I forgot what it's called, that also does some network interception for the phone. You can also access if the C2 or the server is publicly accessible. Well, you can access it, but I would say don't go there because I bet that's breaking a bunch of laws and you do not want to do that. And what else can you do with that? If it's some remote code execution, well, you have all the power. You have the God power, and you can do whatever you want. Yeah, I'm done. But there's a lot I didn't cover today because there's a lot, like stuff like the key store in Android. If you don't want to store like some key, it's a security of storing like cryptographic keys on your device, which makes it harder to do some reversing. Don't take my word for that. There's the Android linter, which kind of goes through your code and tells you, oh, this looks weird. You should probably change it. It's more like a syntax observer, but it does more than that because people can write their own like add-ons to it, so you can do more than what the default is. And yeah, I'm done. And oh yeah, challenges. It's right. I try to install a VM that has like an emulator on it. It works, but it's slow. So you might want to install an emulator on your own host machine. I promise there's nothing crazy going on. It's just like you're doing development, nothing bad is gonna happen. But if the VM is not working for you, I also have the APK in the link that you'll see later on. You can also download the APK and install it on your phone. Again, the phone, if you install it on your actual device, nothing crazy. It doesn't talk out to anyone. Nothing bad. You're good. You can, again, on your, if you have the emulator on your phone, just drag the APK, drag it onto the phone, and it installs it for you. It should say RIT-sec, nothing crazy. You should be fine. And you will need some additional tools like ADB and Frida. So when you get there, just, and you have problems, just, I'll be around. I'll be on Discord and all that stuff. Just again, this is what the application should look like. I spent some amount of time making it look nice. So please have fun with this. This is like the first mobile security we had in a while. So I tried my best. Don't make me feel sad. Okay, thank you. Oh, you need